Okay, so for question 2, it asks you to talk about equilibrium of this reaction where 2 moles of gas are becoming 1 mole of gas. Now, I should say that for 2A, you should be just getting that right by now. For 2B, it's simple once you realize that your initial total pressure inside the container is 1 atmosphere because you add all the partial pressures together, and then the pressure inside the container is increasing. Now, what that is telling you is that you must be making the reaction is going in the direction where there are more moles of gas because the pressure is increasing. So as a result, you're going to have a decrease in the PCl5 and an increase in the PCl3 and Cl2. So when you do your ice table, what you should do is you should be doing 0.3 PCl3 plus X, 0.60 Cl2 plus X, and 0.10 minus X, because the ratio of each of these substances is 1 to 1 to 1, so you only use a single X. And then you can solve for the X. Okay. Now, for 2C, you simply use your modified or your equilibrium pressures that you calculated in B. In your equilibrium expression you wrote for A to solve. Okay. Then for D, you increase the volume of the system, you are decreasing the pressure of the system. The system will therefore try to re-increase the pressure by producing more moles of gas, which means equilibrium will shift left in favor of the reactants because there are 2 moles of gas on the reactant side and 1 mole of gas on the product side. Now, EI, the reaction as written is exothermic. Predict the effect that decreasing the temperature will have on the mole fraction of PCl5. If the forward reaction is exothermic, decreasing the temperature means the system will try to make or produce more heat. Forward reaction is exothermic, you have more forward reaction, equilibrium shifts right, the mole fraction of PCl5 will increase. And finally, how will decreasing the temperature affect the value of Kp? Well, if you are increasing the mole fraction of your product, then going all the way back to 2A, your Kp expression, you'll see that the numerator is going to get bigger, so your Kp is going to get bigger. Now, the Lewis diagrams for the following molecules and predicting their shapes. I was very generous in how I marked this, but for your PCl3 and your PCl5, you should have as shown in the answers. Again, it's just about using your Lewis structure rules, which I talked about in the question before. Finally, when PCl3 is added to water, it reacts very exothermically to produce 2 acids. If 0.0158 mole of PCl3 is added to 100 milliliters of water, what is the pH of the solution? Okay, for 2G, the 2 bits of key information that you need to use is that 1, phosphoric acid is a weak acid, so although it will give off H+, the amount of H+ it will give off in comparison to the HCl is so negligible as to not being worth calculating. So that's I understand that's quite a tough thing for you to know how to do, but as long as you know that phosphoric acid is a weak acid and you know they haven't given you the pKa or Ka of it, seems pretty straightforward that you wouldn't need to use it in the calculation. So the ratio is 1 PCl3 mole makes 3 moles of HCl. You're given 0.0158 mole to 100 ml of water. So you know you calculate the number of moles of HCl you're going to make. You multiply it by 10 because that will be your concentration per liter, aka your molarity. And then you do the negative log of that. I think the missing part or the hard part was knowing that H3PO4 is a weak acid and its H+ will be negligible in comparison to HCl.